All right, so now that we've gone through secrets and the features and how it works and all that, let's actually look at some practicals. So what I have here is I got our 3-node swarm set up like before. I'm in a secrets sample 1 directory that you'll see in the repo. And all I got in there is one text file. And in that text file is just a simple username, not even actually a password. There's 2 ways we can actually create a secret inside of Swarm. And one of them is to give it a file, and another one is to pass a value at the command line. So let's use the file first, docker secret create. And then I need to give it a name in the secret database, and I'll call it psql user. It doesn't have to be the same name as the file, obviously, but I'm just going to call it that. And then it spits back the ID like it does for other objects. And let's create another one. Let's actually put the password in. And this time we're actually going to echo it from the command line. So if you see what I'm doing, I'm actually typing out a password in the command line with echo and echoing it into the creation command. And notice the dash on the end, because that's telling the command to read from the standard input, which is what we're giving it with the echo command. Now I should say that both of these have drawbacks. The first one, you're actually storing the password on the hard drive of the server on the host, and we really wouldn't want to do that. So maybe you would be using the remote API from the local command line on your machine and then pass in the files that way. And in the second one, it's actually going into the history of our bash file for our root user. So then technically if someone were able to get into root, they could actually get this password out. When you're dealing with your own production systems, you'll need to look at various ways to get around these 2 potential security concerns. So what we have here is now, if I do a docker secrets ls, you see that I have both of them in there. Now, I can actually inspect them, but I'm not going to ever see the passwords or the actual secret. So let me just do the user. It's not going to give us the information, right? Because if it was this easy to get the information, it wouldn't really be that secret, right? So the goal here is that once you put the secret in the system, it's stored in the database, and the only thing that's going to have access to the decrypted secrets are going to be the containers and services we assign it to. So let's do that now. I'm going to create a service manually. Docker service create. I'll call it psql. And we're going to map the secret to it. Basically, we're telling this create command, take this secret, call this particular name. I can also use the ID of the secret and assign it to this service so that all containers in this service will see this secret. All right, and then we put the user in there, and then I got to do it again for password. Okay, so this maps the secrets to the service so that they show up as files inside the container, but it doesn't tell the Postgres database that we're creating from this image how to use those secrets. So usually we need to do something with the configuration of the image. And in this case, the official images from Docker Hub have settled on a standard where you use environment variables, but instead of passing in maybe something like Postgres password, that would be hard to use with a file. We'd have to actually like cat out the file into the environment variable, and that's a little bit of a pain. So they have this standard where if you specify a file, and this would be the path, so it'd be run secrets, and then the name, right? So psql pass, the name of the secret. So if I do that, that's actually in the startup of the image that will look for this environment variable being filled out. And if it is, it will then pull that file in and store it in the environment variable, the actual contents of that file. This is a really easy way to consume these secrets that are in the files, but it does mean that the images you use need to have this standard in place. We can also do the same thing for the user. So hopefully this makes sense to you. When I create the service, it's going to do the typical thing it does when it issues a scheduling request for a new container. It's going to create one Postgres database, and it's going to pass it the environment variables for the locations of those 2 secrets, and then it's going to map in a temp fs. It's actually going to map in what look like files, but again, it's really just a RAM file system or a temp fs. So let's go see what we can see in there. So I do a docker service ps psql, and that should tell us what node it's running on. Okay, it's running on this node. So let's do an exec to see what we can see inside the container. Docker exec -it, and then the specific container name for that service, and then bash. All right, so now we should be able to do an ls on run secrets. And you'll see we got the two files there. And if I do a cat on psql user, we see the value. It worked. And if we look at the logs of that psql, we actually know it works, because if it didn't have those files, the actual database would keep recreating itself and not be able to work because it didn't have a password and a username to create the database. So if we did a Docker service ps again, what you would see if it wasn't working correctly in a database scenario is the database would actually be failing and it would keep restarting, and you would see new containers being created here. So now that we've actually assigned it to there, we can actually use a Docker service update to remove the secret. So Docker service update --secret-rm. There's also secret-add. But if I removed one of these secrets, what would actually happen is it would redeploy the container, because secrets are a part of the immutable design of services. If anything in the container has to change for the service will not go in and change something inside the container. It will actually stop the container and redeploy a new one. Obviously, that's not ideal for databases, so we're going to have to come up with a different plan for how we would update database passwords, and that's something we can talk about later. For now, I just want you to know that you can remove them and add additional ones to an existing service. It's just going to recreate the container when you do it. All right, now that we've seen secrets with services, let's look at secrets with stacks. In this directory, I'm in secrets sample 2, and in this directory, I have a compose file and then 2 secrets stored in text files. So it's the similar password and usernames that we had in the previous lecture, but now we've defined all this in a compose file. And we have several things different here. So the first thing is the version of your compose file now has to be 3.1. In order to have secrets, we have to be at the .1 release of 3. So we needed to have 3 in order to use stacks, but to use stacks with secrets, we need it to be 3.1 or newer. The second thing we'll notice is that down here at the bottom, we have this root secrets key now, and it's where we define our secrets. Now, the two ways you can do secrets in a compose file are either using a file for each secret or have the secrets pre-created. And here, we actually are just using files, but what we could do is create those secrets on our own in some other method, either through the CLI like you've seen, or maybe through the API directly. And then we would just, instead of the file colon underneath it, it would just say external colon, and it would be the name of the secret inside the secrets list. We need to tell the compose file about our secrets and where they are, and then we actually assign them to the services that need them. And that's key, because what we're really saying here is that only the container that wants our secret gets our secret. And if this was a complicated compose file where we had multiple services, we may have different secrets for different services. We would first define all of them down at the bottom, and then we would assign them specifically at each service. Now, I will say that this is actually considered the short form or the easy way to do the secrets under a service. There's actually a long form that allows you to define things like the permissions and the users that are allowed to access that using standard Linux mode and user ID syntaxes. So if you were running applications as a non-root user, you'd want to target these secrets to only that user being able to access them. But for simplicity's sake, in this first example, we're just using the short form. All I need to do is use that file in a standard stack deploy command. So deploy docker compose, and we'll call this mydb. And you'll see, just like before, it actually created the network first. In this case, it actually created the secrets first and then created the service. If I went and did a docker secret lookup, then you'll see that the two are in there, and it follows the same naming convention as all other stack components, where it's always the stack name and then the name of the object. Just like in the previous lecture, if I jumped on the SQL server and actually looked for those files, they would be there just like they were before. only now they're managed inside our stack file. The nice thing here is if I remove my stack, it also cleans up the secrets and gets rid of them. In the previous example, if we wanted to remove our secrets, we would have had to do a docker secret rm to actually remove each one. And just as a last reminder, in these examples, we've been using text files on this server, and we're talking about a 3-node swarm here. But if you're in a production environment, or really anything that's not on your local machine, you should not be keeping the secrets in files or in the bash history file or any place that could possibly be on that host. That's kind of defeating the purpose of having the secrets in the first place. Whatever your process is for getting secrets into the swarm, just know that you may need cleanup once you're done there so that you don't leave residual secrets around that are easy for people to get.